All right, everybody, welcome to BRK 3321. My name is Larry Prasad, and I have...
And I'm Abhinav Mittal. I'm one of the engineering managers in the Cambridge office.
So today we're going to talk about cloud systems of intelligence design patterns. Hopefully some of you guys have done something similar in the past with some of the projects you're working on. Our main objective of today's presentation is to go through a few use cases that we've managed through a set of customers and walk you through some of the trends within big data analytics and AI as well.
So let's start with the purpose. Why are we here? So AI-powered organizations are rapidly getting ahead of rest of the crowd. And with massive compute power, deep neural networks, and advanced algorithms available on cloud already, massive amount of data is getting transformed into information daily, which is powering all of these powerful apps. So when companies start to build these apps, unfortunately today it's a long process, time-consuming, buggy, and we are here to make this process shorter to reduce the time to production.
So as you all know, these are the key trends. Microsoft has been talking about this for a few years now. And data, as you know, is a new currency, first-party, third-party data. The first thing that you are probably aware of is as you start to get into these full end-to-end solutions, the first question is, where's the data, what's the data, what does it look like, how do I kind of manage that data set? And we're not talking about small data, but we're talking like large data. Then the other part to the whole trend is that, of course, cloud is one of the center of focus, but it's now bleeding into hybrid cloud, multi-cloud. It's not just one provider. It basically goes across multiple providers. It also would mean private and public. And on top of that, so your data coming into the cloud and then ultimately bringing intelligence to it. And it's not just about visualization or a dashboard that shows some rich advanced analytics, but it's also like edge computing, so things that are on the edge which have fast compute power, whether it's a drone device that's collecting data and then has to analyze it and then pass it off into a back-end system that's hosted in the cloud. These are the trends that we're seeing today, and we're going to walk you through some pretty high-level use cases with some of our top customers that we work with, so you get an idea. The goal is that as you leave the session, you can start building these big data design patterns within your own organization. Now, there are two facets to this. What we've seen is that within Microsoft, in most cases, when we start to think about a problem to solve within the industry, we may sometimes add a lot of resources. So we might be on the far right-hand side or left-hand side of this graph, where you just basically take resources and apply them to some business problem that we're facing in the industry, or a variety of things, or we're building out a product. And then the other part is that you're thinking about a solution to build out, and you want to basically just tether the industry, figure out what's going on, basically test out a set of use cases, and then from those use cases, you kind of nail the solution. What we've done and what we're about to talk about is we collected over 100 customers we spoke to, and Abhinav is going to get into the little details of them, and we zeroed in on 7 of them. These are very top ISVs, and you probably use their products today in the cloud. And what we figured out is how do we then develop design patterns so that we can identify the specific use case. In other words, we didn't go from the left-hand side, we started from the right-hand side, and find the specific use cases, divide up the parts that can basically come together from data ingestion all the way down to processing and then analytics. And then from that, we basically came up with a set of solutions that we can build and share with you when you decide to go on these large data set projects. As a data scientist, there are very common workflows that we typically go through, right? So from the point of, here's my data set, small, micro, macro, large data set. And from those data sets, we basically want to understand what does it look like? Is it real time? Is it data at rest? How fast do I need to process the data? The benchmarking things I need to deal with. When I start wrangling the data, meaning I start mashing them up together, normalizing it, and then featureizing the data, meaning I'm trying to do some machine learning on top of that data. So once I've been able to do that, I process my information, I store it in the cloud. It might coexist both real time and at rest, so we might have a hot path or a cold path, we refer to them. And then ultimately, then we start to normalize the information and building our machine learning models. We start doing our experimentation in the cloud, and then at the end, we have our application that will consume that data set. And these things can happen from things like fraud detection. We'll get into those scenarios later. But the ultimate goal is that we're able to manage this through a process from data ingestion to experimentation to collaboration, and then adding documentation around that. We're going to walk you through these today, and we're going to highlight two very critical patterns that we're using, again, with some of our large customers. Some of you might be familiar with this. This is our systems of intelligence platform to deal with the big data architecture that we're going to talk about. So on the left-hand side, you have data sources, or your right-hand side, you have data sources, apps, and sensors. So basically, a device might be sitting in a hospital. It's an IoT sensor. It's pumping data through, and you have to collect that information. The information is either coming in at a certain speed. You need to have events that's tracking the information. You need to make sure that it's not duplicated, and so on. So we have a set of things in the first column, which we refer to as information management. From information management, and then we go into the big data store. So whether it's structured, unstructured data, all types of information, how do you then couple it together, store it into a data warehouse or a data lake. And then we then add now the processes for machine learning. So this is where you actually start to create your models, your ML models, and starting to experiment on that data. Then you're going to analyze the information so that you can do some feature engineering and some training and scoring. And you might have classification, you have boosted trees. So that's really where the algorithms will sit. And then moving on now, you have intelligence. We didn't have that before, but just recently we released about a year now our intelligence platform from Cognitive Services, the bot framework, and Cortana agent. And then at the far end, you have now the data dashboards that visualize that information. But I think what's really important here is that you have information that's flowing across the stream, across a pipeline. Then the information gets processed. And then on the far end, you might have line of business integration. So if you're a car manufacturer and you're trying to deal with something, say robotics, that information is flowing across from, say, the plant all the way down to a data center, then to the cloud. Then ultimately at the far end, you have your line of business systems. You may need to order parts. You may need to integrate with other people on the shop floor. You may need to call a distribution center. So that's really the upstream effect, how these things get are integrated. So you have data intelligence and then action that's occurring on the far end. So Abhinav now will show you this in action. We'll walk you through a very quick demo. Then we'll come back now and start walking more details through the design patterns and the architecture associated with those patterns.
All right, demo time. So before we start the demo, this demo is basically about the intelligence piece that Larry was just talking about, the bot framework, the cognitive APIs that we have. It's called the Interactive Voice Response Bot. This demo is available for you guys to download on Cortana Intelligence Gallery. You can find it by looking up Interactive Voice Response Bot. Just type it up, and then this page will show up. What in effect this is a product ordering bot, a very simple bot per se, but it gives you the foundational piece of building other more complex bots on top of it. There's a one-click deploy button if you see on this page, which enables you to deploy the whole solution in your own subscription in a matter of about 10 minutes. Costs you about $11 a day. But more fundamental stuff is, and I'll go a little bit deeper into it later, is on the GitHub we have released all of the code, all of the artifacts that are needed in order to build such a system. So let's see if the internet cooperates. Let's go into this demo. I've already pre-built this bot using the same solution. Let's call into the bot. And actually, before we call into the bot, let's see what we want to do with the bot. So I'll try to find some product details with the bot. I'll interact with the bot to place an order, and then we'll probably check the order status. So let's call the bot. And the bot is called using Skype, which your end customer would be using. So this is not Skype for Business, just regular Skype.
Hi, please say a product name.
Tell me more about bike wash.
Here's what I found for bike wash. Washes off the toughest road grime, dissolves grease, environmentally safe. 1 liter bottle, starting at $8. Hi, please say a product name.
I want to order a classic jersey.
Okay, please speak your customer ID.
All right.
For this demo, you may speak any 4-digit number.
1, 2, 3, 4.
Welcome back, Mr. Brian. Your order, number 71895, has shipped to Futuristic Bikes in Culver City, California. The balance on your order is $273. Would you like to hear the inventory for this order?
No, thank you.
Hi, please say a product name.
So this just gives you a basic foundation of interacting with the bot framework, building a system where you can add LUIS, which is our language understanding system, interacting with Bing APIs to convert your speech into text. And a lot of this would be shown into action. I'll have a slide later in the deck. If time permits, we'll go a little bit deeper into it. But here is the cool thing that I was talking about earlier. So this bot itself, we are releasing everything on GitHub. You can go to the GitHub. You'll see there's a business audience guide and as well as a deep technical audience guide. And it gives you some basic understanding, at least on this page. But if you are a more of a technical audience, this is the right page for you, the technical development guide. It gives you step-by-step way of building your own bot and customizing it. So for example, if you go to this section, it talks about customization. What do you do with LUIS? How do you identify different entities? How do you use it with Azure Search in detail? And similarly, how do you scale it out to build a much more massive platform around this? Also, all of the code that is behind this bot, if you remember, the bot kept on saying in a loop, hi, please say a product name. So these kind of things you can tweak on your own. You can, these are simple files you go edit and then you can deploy it. And the idea here, like I was saying earlier, is all of this journey today is very long and we are trying to build these products to shorten this journey. Now, the real question is, how do we figure out which solution, which product to build? So I think Larry is going to take us into the customer journey where we have realized certain patterns, and he's going to talk about those patterns.
Yeah, and the key thing here is that the walkways that we white labeled these use case scenarios, and these are highly scalable compute of like roughly maybe petabyte of files on the minimum that we're transferring in from on-premise to the cloud, processing it, adding machine learning, and then what Abhinav just showed you is then you put the AI layer on top of it. So data, you have data, you're basically using the data, you have machine learning using the data, and now you're taking AI, like the cognitive services pieces that we just went through, and Bing search and speech to text to show a more modern way of approaching the data set. So we focus roughly around 6 industries, and I'm just going to show 4 today. And these are top industries from manufacturing all the way down to healthcare. And we analyze over 100 customers, and these are, again, large customers, Fortune 500 customers, and we tailored it down to 4 industries in this particular slide. Several use cases from quality assurance to fraud detection, all the way down to insurance fraud prevention. So like your banking website that you might go through today, there might be some fraud detection that's going on. It's using this platform to do that. If there's any type of like products and services or ad campaign that a bank might or financial services institution might be trying to instrument to you, they're using these platforms today to basically supply some advertisement mechanism. Now, in these use cases now, we discovered a set of design patterns, and that's the purpose of the session today, right? To harvest these patterns, explain to you what they are, because what we've discovered is that regardless of the customers that we're talking to, in many cases, we sometimes even repeat the design and not really pay attention to what we've delivered in the past to, say, another 10, 20 customers. So we harvest that IP, and we're now bringing it back to product engineering. So the patterns that we're going to walk through in a lot of details today is the batch big data processing at scale. So basically, you want to set up an enterprise data warehouse. How would you go about doing that? Typically, these are large projects, and they can go on anywhere from 9 to 18 months. We're in the process of publishing the patterns so that it can really reduce that time to production by 50%. So you can perhaps get an enterprise data warehouse stood up in around 6 to 8 months, fully scalable and operationable. Then there's streaming processing. So you might have a car that's like as an example, IoT device that's sensing information, sending it to the cloud, and then we want to report on any type of anomaly detection that's going on. So this is real-time prevention. And then finally, how do you then operationalize that in the cloud? How do you bring machine learning to the cloud so that you can scale it out based on these needs from the design patterns that we just mentioned? So there are several architectures, and Abhinav is going to walk you through the details. So I'm kind of setting up the context of what they are across the industry, the use cases. Now we're going to show you the details that's involved, and it's really complex. And we're going to then tailor it down to a optimal pattern that will break it down from open source technologies to Microsoft technologies, how we blend those two together to come out with the best outcome.
Thank you for mentioning they're complex. So I think they're complex usually because there are slight nuances. As you go from one architecture to another, you'll find that they are serving the same purpose, but there are nuances, and these nuances are sometimes introduced as more educated and intentional nuances, but many a times, actually majority of the times, they are just because people do not understand the full technology, or there's a product gap, or their understanding of products is different from what the product does. At the same time, sometimes people are just curious about new products, they end up using those products in wrong ways. So here's an example of a big data processing stack, and here we are showing a big data processing stack that could use HT inside Spark cluster in order to process large volumes of data, like terabytes of data that Larry was talking about. A similar architecture could be if you follow the white boxes this time, would be using Azure Data Lake Analytics. Yeah. And then the third approach could be using SQL Data Warehouse if you follow the blue boxes this time. So which one of this is right? I think all of them are right. It's really what is that you want to do with all of them. And what we have done over last 1 year, we have identified the sweet spots and the happy optimal paths from all the way from ingestion of the data to the consumption of the data. So the patterns that we are talking about, they would cover 90% of the use cases in the large enterprises that Larry has been talking about, rest 10% being the long tail. And the idea is that if we can fix those 90% with 3 or 4 patterns and make them industry standard patterns, they are going to last much longer. There'll be less debugging required. There'll be more robustness. The products won't get delayed. And ultimately, we all want to ship great products at the right time.
Yeah. And part of it that, before we jump off of this, the reason why we did this is because as we start to club together the technologies, we find that the customers and our products may not work as seamlessly as we would like it to. And these use cases are testing it from end to end. So, you're bringing in Kafka into the mix. You're bringing in, Spark streaming analytics. You're bringing in third-party tools that might be hosted on a competitive platform. The resident data might exist, on AWS or GCP. So all of these things come into play, and then there's IaaS mix inside of that too, right? So it's not just one component, but we're showing you what Abhinav explained there. We're showing you end-to-end how these things come together. I think, Abhinav, we should explain the rows, like why did we put that scale-out model at the...
Yeah, so I think, like Larry, what you just mentioned about the scaling, scale is just one of those aspects. I think one of the other major thing, like I was talking about earlier, is if there is a sound reasoning behind deviating from a pattern into another pattern, it's all good. But if we lack that reasoning, we don't know what we don't know. And I think that's where Microsoft is here to help. And that's the reason we are building these solutions, to figure out what are these sweet spots of scale. When do you use big data batch processing? When is streaming going to be very important? Many people come and tell me, hey, I have this great streaming use case. But why do you want to do streaming? It is going to be expensive. If you can't reap the benefits out of streaming, please don't do it.
Yeah.
So with that, Larry, would you want to show the first
pattern? Yeah.
First pattern here?
So the idea is that that's confusing. It's very time consuming when you experiment with the various options there. Sometimes you run out of resources, you run out of funding, and we're here to help accelerate that path. So the first one is really around big data processing at scale. So you're ingesting data, you're collecting to many different data sources, not just one data source. It's not a unique pathway that it's taking. It's going through real-time sensors, as I mentioned earlier. It could be a hospital, a patient room information that's getting data is being collected from the bedside, processed, security applied to it, then the rules then push it into the cloud. Then you harmonize the data. So you get all of these data sets that are coming in, you harmonize it, you figure out what the identity matchings that needs to occur, and then you're going to featureize the data. You're going to label the data. You're going to figure out how they tie together, how they do not tie together, whether the data is good, bad, does it make sense. Then you create these aggregated series, right? So you might have some lags in the information that's coming in, so you have to be able to properly timestamp the data. And then ultimately, you're going to build out your algorithms. They might be out-of-the-box algorithms that you'll choose, but they might also be ones that you'll create on your own. So a data scientist might want to test small data sets on-prem and then push it out into the cloud and then basically scale out and operationalize it. So these are the real cases that we see today. And we've done quite a bit of research looking at also papers that were written, other types of customers that are facing these issues, and we came up with a really fast way of identifying how to achieve a standard Lambda architecture for big data processing at scale. So at the first path, you have data at rest or data that's streaming, real-time information, and you have to decide whether you're doing a hot path versus a cold path. Then you might have large sets of data. So say, for example, you're setting up your data warehouse for the first time, and a terabyte to a petabyte of data or a zettabyte of data. You don't want to send that to the cloud. You may just want to be able to ship a disk to the cloud provider and have them just copy that and move it into the data center. So that's one aspect. The other aspect is that we use the ADF, which is Azure Data Factory, to basically pull in information. It has connectors onto the data sources from origin. Then it orchestrates the information to Blob, which is Azure Blob. It stores it there. And then you might then have it, you start preparing. Now you're cooking your data, you're creating that pipeline, you cook your data. But it may not just be an HCI Spark cluster that you'll use. It could be a set of virtual machines. And we've had customers where they mix the two things because of the fact of the sensitivity of the data and where they want it to be stored. And then finally, you get into the analyze stage, and then you move into staging the information so that you can then push it off to another data store where your application can then connect into that data store and then start rendering the information. So you might have a mobile application, you might have a line of business application, you might have a Tableau as the dashboard, or Power BI as an example as well. So this is a typical pattern, and we're in the process of making that really complex diagram that Abhinav just showed, so that we call this the optimal path, so that you can achieve a data warehouse in a very, very short time period.
Yes, and I think one of the interesting points here to mention, Larry, would be the 6-stage architectures that we have come up with. So if you see here in this diagram, we have 6 stages: ingest, store, prepare and transform, analyze, then you stage it, and then finally you consume it. So following these 6 stages, what we have figured out is that you can swap. If you are building multiple solutions, you could swap out any stage from one solution, which is fully tested out stage, and use it anywhere else. So let's say your ingest store happens to be a data lake, right, which you have already tested out. You don't need to develop it again for another solution which is going to use data lake. It could be doing some other kind of analytics. It could be using transformation of different kinds, maybe deep neural networks, maybe HD insights or something else. We don't care. As long as the ingest is same, we can just use them as interchangeable parts. So you test it once and you start building it on top of those. So let's go to the next. So here's the second pattern that we wanted to talk about. So remember the demo I gave you about 10 minutes ago, which was around the IVR bot, interactive voice response bot. That made us start thinking about a second pattern in cognitive search. We're calling it AI-powered content match. But before we go into that much deeper, let's figure out what was that bot doing. So if you see in this diagram, it has the same 6 stages we were talking about. In the ingest, we have Azure SQL database, which is storing all of our product inventory. So that's the source of truth. Anytime new products are added, they get added into Azure SQL database, and then the rest of the components just seek information from that.
And Abhinav, those would be jerseys, right, or things from the product catalog?
Yes, okay. Exactly. Those will be like mountain bikes if you were going for a bike rental company, or it could be jerseys if you're going for a clothing company, for example. So here in this diagram, let's quickly look at the real-time and the ETL process. So the real-time flow is really the consumer flow. So, and we start from right to left. So look at the consumer calling into Skype using the Skype client. Then the audio is managed by the bot connector, and it's sent to a web app, which is basically essentially a bridge between the consumer and the backend system. So the first thing that the web app does, it goes and creates a session and stores it into Cosmos DB. And then it takes the audio, sends it to Bing Speech API, gets the text out of the audio. Using that text, it sends it to the LUIS system, which is Language Understanding Intelligence System, to drive intent and entities. So is the consumer trying to buy something? Are they trying to view the order of their status of their order? Or are they actually just inquiring about a product? So, and what is that product? Is it a jersey? Is it a long sleeve jersey, short sleeve jersey? So all of these entities, etc., are extracted using LUIS. Then the third step here is we construct a query that is then submitted to Azure Search. And Azure Search, together with the data sitting in SQL database, comes up with a set of 2 or 3 good answers, which are then surfaced back to the end user as a prompt. So while developing all of this, we said, hey, this looks like a more generic architecture. We can actually build a lot more cooler things, because essentially what we were doing, we were doing intelligent match and search. So we have come up with second pattern, which we repeatedly see in media. So when people want to add news articles and video clips together, for example, or they want to search for a resume given a job posting, or they want to figure out is this kind of a case already been, is some court has given a ruling on this kind of a case before. So all of those use cases actually require you to match and search, but we are adding intelligence to it. We are adding context to it. So in this diagram, if you see from the top, there are 3 tiers. The first tier is query and result orchestration tier, which is basically the bridge, like I was explaining earlier, between the consumer and the backend. So backend comprises of the middle layer and the bottommost layer. The middle layer is basically the brain of it. It's the cognitive API layer or the intelligence layer. It includes Azure ML. So things you can do classification, you could do topic extractions, etc. LUIS, which we just covered, to extract entities and intent. And then you can have custom recognizers like Bing Speech API. Then the last layer is basically the search and surfacing layer, where you have custom analyzers you can add. You can add textual similarity. There's a concept for stemming. There's a context. There's a concept around synonyms. How do you remove these synonyms, or how do you merge them together? And you can also filter and boost your data sets. So just if you see the flow of it, as the incoming query comes in, the query orchestration layer first uses the cognitive API to enrich the query so that it can ask a more meaningful result from Azure Search. So Azure Search then would go back and say, okay, these are the 10 things that I found which are really relevant to you. Then the result is then again enriched, looking at the original intent and the intent that search is giving us back, and then we can feed in the response outside. So tying it back to, again, to the demo that we saw, it's very easy to build that demo without any intelligence, just rule-based, but it's always going to be very artificial. It would not understand anything outside of what you have just taught it. It would not understand if a person is saying, or maybe it would, but it'll take you years to build it. With machine learning, it's going to be much quicker. So instead of somebody saying large, if they end up saying L, can the system understand it? So with machine learning, you can add these nuances to it much more easily and deliver a solution within a matter of few months instead of years. So with this, Larry, you want to talk about more interesting stuff that we have encountered?
So what we've covered today is really things at the lowest layer. So we have storage, so again, the data that's coming in. And the patterns that we showed you, we're going to be deploying a set of templates that you guys can access those templates that configures the entire back-end system. So end-to-end, from data ingestion all the way down to processing, machine learning, the entire infrastructure, the IaaS and PaaS layers, is going to be constructed. You just click on a button and you get that entire infrastructure configured for you. Then you customize it on top. So what we've actually seen, in the past few months now, and it's not, some maybe a year or plus, but I would say for me, and perhaps you, Abhinav, as well, maybe less than a year, is that we've done several of these large-scale data customer engagements, and we also bring that back into the product, and we engineer the product to fulfill the gaps and make them work nicely together. But what we're starting to see, so beyond the model experimentation, data storage, processing, and classification, and all the various things associated with artificial intelligence, there's then the other SDKs that we've applied recently from cognitive services. So for example, the intelligent bot that Abhinav just spoke about, it uses each component within here. And what's more interesting now is that we just released a product called Vienna. You guys might have seen it at the keynote yesterday. But theoretically, what happens is that you can bring in even third-party libraries like TensorFlow and Caffe and PyCharm and all these other things and start using it along with these design patterns. And then ultimately on top of that, you have the applications that's surfacing as part of those SDKs. So you have data and frameworks that's on the far end, and then you have this engine in the middle. And then on the far end, you're kind of inferencing with a Docker, so you want to operationalize your data moving into Docker containers. So we allow you now to say, for example, you train a model in the cloud. You train a model like on your server, your desktop or something. You're doing very small sets of experimentation. Now you want to scale it out to the cloud. So you push it now into perhaps an HCI Spark cluster. But let's say, for example, you want to take that model and train it on a drone. So you might have a drone that's flying around looking for some anomaly detection. So the model is now on the drone. It has images that it's looking at, and it's processing that information in real time, and then it's sending some of that to the cloud. So these are the use cases that we're seeing how this platform comes together. So, nice cloud AI stack. We love it. It's pretty rich. But what's really interesting is that how does it help the developer? Because the developer now has to think end to end. They have to go from the bottom all the way to the top, and then they have to figure out what tools, what first-party, third-party tools can they use, what API sets they can build out, publish those API sets. So the idea is that we've done the data parts now, the data patterns. Now we're going to bring AI on top of it, and now we're going to have our tool sets to enable this entire journey. So from a DevOps perspective and those types of things, all the other systems of intelligence that's out there, we're bringing it all together into one place to make the lives of a data engineer, data scientist, and a developer easier rather than them having to flip across many different types of workbenches. So we assemble all of that into this system of intelligence, and I think it might be worth for us to show some of the things that are on the AI page. So let's walk you through a little bit of what we just published and then the gallery. And then we'll get to the conclusion. So we launched a Azure.com AI yesterday. And what you'll see there is what I just spoke about and what Abhinav shared as well. And this is the gallery. Abhinav, you want to give us an overview of these things?
So periodically, actually more than periodically, we identify these patterns. We build the basic solution out of the pattern. And we deploy all of those here on Cortana Intelligence Gallery page. So if you go here, every few weeks you'll see newer and newer patterns would show up here. And they all have the technical guide that I was showing you earlier. They have the full code and the basic understanding that is needed in order to build and sustain such a solution. So one was the interactive voice solution that I talked about. There's oil tank forecast here, which is one of the very popular ones. Another popular one we have is the population health management. There's also stuff which is very, very fundamental, like customer 360 profiles. So it's all over the map from retail. Yeah. So I can click on it and show you. So from retail to lead generation to customization, so making personalized offers, etc. All of them require you to build an enriched customer profile to know your customer.
And I think we talked around, we talked about the patterns. This is the architecture that Abhinav and his team put together. You can then download, this is free source code. It has all of the bits assembled for you, so you don't need to spend months trying to do this. You can actually get it up and running within less than an hour.
Yeah, and it also explains to you things like data virtualization. So many times people assume that in order to build such a system, you would want to move all of your data into one place, which is the biggest mistake. You can't move terabytes of data into one place. So these kind of solutions will help you diversify your understanding about what can I do without moving my data? How much can I do without moving my data? Is it even possible to build an intelligent system without moving my data? So I think with this, probably we should conclude and have some time spare for questions.
Yeah, and just before we get there, you guys probably saw this yesterday, but I just want to walk you through it very quickly. So here we just launched this yesterday, and it talks about the AI platform. The things that what we concluded today was around data ingestion preparation, cognitive intelligence, experimentation, deep learning, and deployment. So you have tools, services, and infrastructure. So we put this all together for you guys, and it describes the moving parts in the architecture bits. And then from that, you can also look at the third-party tools that we're supporting, right? So TensorFlow and MXNet and so on. And Abhinav mentioned the architecture patterns that we have. So on this site, you can pull down at least 12 of them. This is one for convolution neural networks. And if you click on this, it'll walk you through step by step what it is. And you can then download the source code from GitHub. So you can basically go to GitHub and just pull down everything, right? So you just say browse GitHub, and you get that there. And then the final thing I want to show you guys is that we've published, so from the architecture diagram that I just listed, here it is in action. And we developed this white paper that will walk you through the entire platform, like how to do it, how is it used, first-party tools, third-party tools, the building blocks for a developer. It actually walks you through as a developer that journey. And then it gives you that really quick start of these examples. Okay? So now we'll switch over now to just do the conclusion. And this is part of like it's an architecture session. It's not I'm not going to write code and show you guys that, but let's conclude now with a few takeaways.
So I think the few things that we covered today was the Microsoft recommended architectures. Why is it important to first understand what you want to build and how you want to build? Understand the business use case first and try to determine if building a product around that use case is actually going to serve your business. Second is try to use whatever you have already. Do not try to reinvent just because there's a new technology out there. Does not mean that you need it immediately. You should look at the best practice architectures, and we are helping build these best practice architectures and publishing these for you. Microsoft, and these will be the Microsoft first-party enterprise solutions that we'll be publishing. These are fully vetted out enterprise-grade solutions. When we publish, we'll give you, the nutrient facts, for example, right? That it can sustain, let's say, 1 terabyte of data ingested per day. And it can process 300,000 rows or per minute or 300 million rows per hour, so on and so forth. Use them as foundational principles for building your own solutions. We also walk through the customer journey. So these solutions that we are building are actually built using the information that we have learned from all of the customers, looking at their use cases. These are really well-established, deep industries and common use cases that we are encountering. And to conclude, I would just say, hey, be a AI-powered org, because that's the future, and I think nobody should miss that future.
Thank you, guys.
Any questions, anybody?
Yeah, can you go back to that slide where you have the big data stream? I think you're using stream analytics. Are you just using that as a pass-through, like a select stop?
Yeah.
Have you heard of event hubs capture?
Yeah.
Save a ton of money and take out that component, saving customers a lot of money that way.
So let's repeat the question. Let's first go to the slide.
So the question is, instead of using ASA, you use Event Hub for a cost savings.
Yeah, event hub
Capture,
It just
yeah.
dumps it right into storage or
Yeah.
DLS.
Yes, so I think it's a great question. Most of the time, if it is a pass-through, you should not be using stream analytics for a pass-through.
Yeah.
It is really in order to do something in real time. So if it is in the real-time hot path, then you can actually call machine learning APIs directly in the hot path. So as you are ingesting the data, you can do certain predictions and move forward with the hot path.
Yeah. Any other questions you guys have?
How does the governance piece really fits in? Because when you're doing any customer 360 viewpoint, I mean, coming from a data science, like garbage in is garbage out. I mean, you're still processing a lot of stuff. but you need to be like from a qualitative to a quantitative mapping. There needs to be like the data discovery piece that needs to be mapped in to really identify, okay, this is what I'm analyzing. It's great to integrate a lot of stuff,
Yeah.
Yes.
but it's not quantitative validated.
So the question is around data governance.
Yeah, so I
We
think
hear
it's
that all the time, by the way.
Yeah,
Very
I think
often.
this is a great question. We had a slide which we removed. I think if it is at the back, we can show. But that's where Azure Data Catalog comes into the picture. That's where the data discovery comes into the picture. And it's all like really tying into the fundamentals of building a platform for a company, right? So if you have the right foundation where people can curate the data, they can annotate the data, and data scientists can then discover the data in a systematic fashion, I think that's the beginning.
Yeah, and I think there are many, you know this, there are many different levels of governance from a maturity model, whether it's like, you have a committee before you access the data, all the way down to applying it with the tools. Yeah.
But doing it in an agile fashion, I mean, you don't
Yeah.
get into like, you don't get logged into what you're trying to do, but
Yeah.
at the same time, you have a qualitative to quantitative mapping, because like it's, all of the things are really great, but it's like unless things are tied together,
It doesn't, yeah, you're absolutely right. Yeah, I totally agree with that.
And most of these mechanisms, I mean, like a lot of them work on an open source implementation designs.
Yeah.
So how does this really help? Like, okay, some of the pipelines, what you've built, can be really taken out of like, okay, I'm not an Azure user because like coming from an utility industry, so like we use like Amazon and as well as Azure. Both.
Yeah, of course.
So like it needs to be like compatible that I can bring it from here, move it over here.
Yeah, and that's the whole idea. Yeah, because what we've seen is that in the complex diagrams here, a lot of our use cases are this, right? And it's even more. Sometimes it's even wider. So our goal is to be able to support as many of the third-party tools from our point of view and services, but sometimes you can make this a lot easier. It doesn't need to be this complicated. Yeah. So our goal is to simplify it.
Okay.
Thank you.
Thank you.
Any questions? Any more questions? Thank you guys for coming out.
Thank you.